Hi everyone, welcome to my Maths Academy. In this video, we'll continue with the chapter Relations and Functions, which is chapter 1 from your 12th standard CBSE Mathematics. We will continue with page number 15 in your textbook, definition 9, which is for an invertible function or inverse of a function. So here what we are going to talk about is how to find an inverse of a function if it exists. Like we have no inverse for numbers, we have inverse for functions also. So suppose if you take in our earlier classes, we would have studied inverse of 2, which means additive inverse of 2 is minus 2, because when you add 2 and minus 2 you get 0, which is called as additive identity. So similarly for number 5, the multiplicative inverse is 1 by 5 and additive inverse of 5 is minus 5. So like that we have inverse for functions also, which we will define now. What is called as an inverse of a function, or when do we say a function has an inverse or it is invertible? Fine. So we'll say a function f from set x to set y is said to be invertible if there exists a function g from y to x, the reverse, y to x, such that g of f equal to ix and f of g equal to iy. Right? A function f is said to be invertible, which means we can find the inverse of a function if there exists a function g, if you are able to find another function g such that g of f should be equal to ix. Ix is the identity function, which means I of x equal to x, and f of g should be equal to iy. This iy is also an identity function, but this function is from the set y to capital Y to capital Y. Here this is an identity function which is from capital X to capital X. Right? And we all know what is an identity function. Identity function I is from x, means it is from set x to x, such that ix of x, small x is the element, that is equal to x. Similarly, our iy is a function from set y to set y, capital Y, such that iy of any element x in that will be equal to x. This is for every x belonging to capital X, and this is for every x belonging to capital Y, where small x is an element from that set. Like f of x is equal to x. That's called as an identity function. So each element is mapped to its own element, right? So anyway, we call the function f as invertible if we are able to find a function g from the reverse of the set y to x. If f is from x to y, g should be from y to y, such that f of g of f equal to I of x and f of g equal to I of y. The function g is called as inverse of f. It's called as inverse of function f. Right? It is also denoted as f inverse. The function g can also be denoted as f inverse. Fine. So which means we call g equal to f inverse, or f inverse is g. Fine. So here the function g is the inverse of f, and we can also say vice versa. F is an inverse of g. Even the reverse logic works. Now next is we have one more a condition for the function to be invertible, which means inverse exists. So what it says is, if a function f from x to y is 1 to 1, 1 to 1 and onto function, if a function f from x to y is 1 to 1 and onto function, then f is an invertible function. Invertible function, which means we can find the inverse of the function. F inverse exists. F is an invertible function. When do we say f is an invertible function, or when we can say we can find the inverse of f? If f is 1 to 1 and onto function, which means it's a bijective function, right? Bracket we can say bijective, because any function which is 1 to 1 and onto is called as bijective function. So similarly, the converse is also true, which means if f function from x to y, right? Or I'll say if a function f from x to y is invertible, then f is, which means f means the function f is 1 to 1 and onto function. 1 to 1 and onto function. So which means the reverse is also true. Which means if a function is invertible function, in case if a function has an inverse, then we can say that that function is 1 to 1 and onto, or that function is a bijective function, right? So this statement says if a function is 1 to 1 and onto, then it has an inverse or it is invertible. Here if it has an inverse, then it is 1 to 1 and onto. So the reverse is also true. Fine. So all of you can pause the video and take the notes of the definition. I'll go to the example 23. Let me erase this. Fine. So now example 23 in your textbook. Now what is given? So given is f is a function. So given statement is f is a function from n to y. N is set of all natural numbers, right? N is set of all natural numbers. I'll probably put a stylish n. N is a set of all natural numbers. It's a function from n to y, and it is defined as f of x equal to 4x plus 3. That is the definition of the function, where y is defined as, the set y is defined as set of all small y belonging to n, set of all natural numbers, such that y is equal to 4x plus 3. That is the definition for some n belonging to capital N, right? Some n belonging to capital N. I'll put this. This denotes natural numbers. I don't want to keep writing a stylish n. So n denotes, capital N denotes set of all natural numbers, right? Now what we have to prove? So to prove is, we have to prove that f is invertible. First is f is invertible, and second that we have to prove is find the inverse. Second is f inverse equal to what? Fine. So we have to show that f is invertible, and we have to find the inverse of f, inverse of this given function f, and this f is from natural numbers to y, and y is what? Y is set of all small y belonging to capital N, such that y equal to 4x plus 3 for some n, for some x belonging to n, for some x belonging to n, right? Which means your y is range of f. Y is nothing but the range of f, because every element is in the form of y equal to 4x plus 3 for some x coming from this. So set of all collection of range, that is range of f is your set y. Now to prove that f is invertible and to find f inverse, or whenever they ask you to find the inverse of f if it exists, we need to have 3 steps that we need to follow. In your textbook they might not have followed all these 5. They would have used some of the definition or the theorem to prove that, or to make the proof shorter. That is also right. Textbook what it says is also right, but to be more logical and to be in a more sequential logical form, we will try to have, or we'll try to follow 5 steps whenever we want to find inverse of a function. The first step is we have to I'll probably write here. Step 1 is we'll prove f is 1 to 1. Step 1 is f is 1 to 1. We have to prove this. Step 2 is f is onto. F is an onto function, right? Then step 3 is once f is 1 to 1 and onto, then f is invertible. So step 3 is we will define a function g. Define g, right? And step 4 is we have to show that g of f is equal to identity function I. And step 5 is we have to show that f of g is also identity function I, right? So we will follow these 5 steps whenever we want to show that f is invertible and we want to find the inverse of any function that is given. Now we are going to follow these 5 steps. Any problem where they ask you to find the f inverse, or they say that check whether f is invertible and find f inverse, we have to follow these 5 steps, and these 5 steps are very easy. So to proof is to show that f is invertible means f becomes invertible if f is 1 to 1 and onto. Once you prove these 2 steps, then f becomes invertible function. If once f is 1 to 1 and onto, we can immediately say it is invertible, which means inverse exists. Then we should find the inverse. Fine. The rest of the 3 steps will show that the function g that we have defined in step 3 will become the inverse of f. Now let's prove that f is 1 to 1. Now how do we prove that f is 1 to 1? So first step 1 is to check f is 1 to 1. Right? Now what is our f of x? Now how do we check if it is 1 to 1? We'll take 2 elements. So let x1 comma x2 belongs to this n, which is domain, such that f of x1 equal to f of x2. So for any case where we need to prove f is 1 to 1, we'll start like this, right? So f of x1 equal to f of x2, then we need to prove that x1 equal to x2. If we prove x1 equal to x2, then f is 1 to 1. Right? Now what is f of x1? F of x1 is this term. F of x is 4x plus 3. So f of x1 is 4x1 plus 3 equal to f of x2 will become 4x2 plus 3. Now what we have to prove? Down the line we should show x1 equal to x2. Which means when the images are same, we have to show that the elements are also same. If the elements are different and image is same, then it becomes many to one function, which means it is not a one to one function. So whenever we want to prove one to one functions, we'll take 2 elements from the domain set n such that their images are same. Then we have to show that the elements x1 and x2 are also equal. Then f becomes 1 to 1. Now again here 3 will get cancelled. We'll get 4x1 equal to 4x2. Then again 4 gets cancelled. We'll get x1 equal to x2. So we start with f of x1 equal to f of x2 and we got x1 equal to x2. Therefore f is 1 to 1 function. So we are done with the step 1. Now step 2. Step 2 is we need to check if f is, or to check f is onto. I'll put it little short. To check f is onto function. Right? So how do we prove that, or how do we check that f is onto function? Means, see, if you see f is a function from n to y, where y is equal to the range of f. Set of all y such that y is equal to set of all y belonging to n such that y is equal to 4x plus 3 for some x in the set n. So which means clearly it is onto, because what is onto? For every element y in this set, there should be an x in this set such that f of x is equal to y. So we'll say clearly, since f is from the set n to y, where y is the range of f. So for every element y belonging to this capital Y, there exists x, right? There exists x, which means there exists x belonging to n such that f of x, there exists such that f of x is equal to y. F of x is equal to y. Or I will say such that y is equal to 4x plus 3. Right? For every y belonging to y, there exists x belonging to n such that y is equal to 4x plus 3, because every y is in this form. So which means, what is 4x plus 3? 4x plus 3 is nothing but f of x. So we got f of x equal to y. Therefore f is onto function. F is an onto function, which means for every y we are able to find x. Because every y will have an x here, because the definition of y itself is like that. For every x, if y is equal to 4x plus 3, form for some x in n. So for any y you take from here, that y will be in this form where x will come from the domain set. So we are y equal to 4x plus 3, 4x plus 3 is what? F of x. So every y is in the form of y equal to f of x, where x belongs to the domain set n. So we have proved that f is onto. So therefore we can say, since f is 1 to 1 and onto, f inverse 1 to 1 and onto, f is invertible. F is invertible function, which means we will be able to find the inverse of once we prove the first step 1 and step 2. Fine? Step 1 and step 2. Now step 3. Now step 3 is we need to define the function g. So step 3. Step 3 is, I'll erase this. Step 3 is to define g. Define function g. Now how do we define function g? Now so to define the function g, we'll have to write your y in the form of, we have to write y in the form of 4, y is given as 4x plus 3. So define g. So for that we'll say y is equal to 4x plus 3, because y is in this form. So this says that we have to write x in terms of y. So to define the function g, before we define the function g, we have to write x in terms of y, which means we will say 4x plus 3 is equal to y, which means 4x is equal to y minus 3. Your x becomes y minus 3 by 4, which this is the meaning of this is called as express writing x in terms of y. So we have to keep x alone here and throw everything to the other side. Throw everything to the other side. So now x is equal to y minus 3 by 4, right? And this will belong to, right? And this will obviously belong to, this is y is equal to 4x plus 3 for x belonging to n, right? Because that is how the y is. Y is 4x plus 3. So when y is 4x plus 3, then x becomes y minus 3 by 4. Now we will define the function. So g is defined as, g will be the function which will prove that g is the inverse of f. So g will be a function from the reverse set, y to n, and we'll define it as g of y. We'll define it as g of y. Generally we'll define it as g of y, because every element in y we are calling it as small y. G of y is defined as this one, y minus 3 by 4. So this you should take it as the definition of g of y. Whatever the x is equal to, that should be defined as the g function, and we'll call it as g of y is equal to y minus 3 by 4. Now we have defined the function g. So step 3 is also over. This is over, where we have defined the function. Now we should find step 4. Step 4 is we have to find g of f. We have to show that g of f is equal to y. So what is g of f? Let's find g of f. So g of f is a function from which set to which set? G of f is a function from f is from which set? F is from n to y. So the starting of g of f will be n to g is ending with n. So it is from n to n. G of f is a function from n to n because it will start from the domain of f. Domain of f is n, and it will end with the codomain of this will be codomain of g. So the domain of g of f is domain of f, and codomain of g of f is codomain of g. So it's in n to n. Now let's find what is g of f. G of f, we have to show that g of f is equal to identity function, which means we have to show that g of f of x equal to x. What is g of f of x? That is equal to g of f of x. That is equal to g of. Now what is f of x? F of x is 4x plus 3. So 4x plus 3. That is the definition of f of x. F of x is 4x plus 3. So instead of f of x, I am putting 4x plus 3. Now this is g of x. And what is g of x or g of y? G of y is y minus 3 by 4. So in the place of y, I had to put 4x plus 3 here. So it becomes 4x plus 3 minus 3 by 4. So in this I am putting y as 4x plus 3. If y comes here, I should put y here. But in the place of y, I have 4x plus 3. So wherever y is coming, I have to put 4x plus 3 here. So here y is coming, so I'll put 4x plus 3, then minus 3, then 4. Then plus 3 minus 3 will get cancelled. You will get 4x by 4, which is equal to x. So your g of f of x equal to x means what? It is an identity function. So therefore g of f equal to I, and then we'll put the set. It is from n to n, we'll put in. So your g of f is equal to identity function on the set n, because when g of f is equal to x, whenever any function is of the form f of x is equal to x, and that is called as an identity function. G of x is equal to x, that is an identity function, and g of f is equal to x we got. G of f of x is x, which means g of f is an identity function. Now step 5. So step 5 I will write it here. Step 5. Step 5 is we should find f of g, and we should prove that that is also equal to I. Now what is f of g? F of g will be from function from g is from where y set to n. So it will be from y to codomain of f is y. So it is from y to y. And what is f of g of x? We have to find. What is f of g of x? That is f of g of x. F of g of x, that is equal to f of, what is g of x? G of x is y minus 3 by 4. Right, so this one, y minus 3 by 4. So here it is g of x, or I can even call it as y if you want. We can take y also, doesn't matter. I'll put y. Y or x doesn't matter. See here, these variables don't matter. Anyway, so y is an element from this set y. We have to find f of g of y. So f of g of y is g of y. And what is g of y? G of y is y minus 3 by 4. So you get y minus 3 by 4. That is your g of y. So now what is f of y minus 3 by 4? Now f of x is what? F of x is 4x plus 3. So you should write 4 into x. X is this one. Y minus 3 by 4 plus 3. Because f of x is 4x plus 3. You should read this as an x. So in the place of x, we have y minus 3 by 4. Right? Now 4 will get cancelled. You'll get y minus 3 plus 3, which gives you y. So what we have got? We have got f of g of y is also equal to y. Which means an identity function. Because y is going to y. X going to x. Those are called as identity function. So therefore, our f of g also becomes I of, I is from which set? Capital Y to capital Y. Here you will put capital Y. So we have proved g of f is I, and f of g is also I. So therefore, Therefore, we'll say, therefore, G is the inverse of F. G is the inverse of F. And what is G of Y? G of Y, we call that as F inverse of Y, because G has become inverse of F. So we'll say F inverse of Y. G of Y is called as F inverse of Y, that is equal to the definition of Y minus 3 by 4 for every Y belonging to capital Y. That is the definition of your inverse of F. Clear? So, as I said, we have 5 steps. Step 1 will prove 1 to 1. Step 2 will prove on to. Then we will say that F is 1 to 1 on to. Therefore, inverse exists. Then we go to step 3 and we define the function G. So, before we define the function G, we have to write what is Y is equal to, or F of X is equal to. Then write X in terms of Y, and this is your G function. Define it. That is end of step 3. Step 4 we will find G of F. Step 5 we will find F of G and prove that both are equal to identity function. Then, as per the definition of the invertible function, right, what the definition says, if F is a function from X to Y, then F is said to be invertible if there exists a function G such that F of G equal to I and G of F is equal to I, then G is called as inverse of F. So G is the inverse of F, which means in the bracket, which means G is equal to F inverse. That is the meaning of it. That is why G of Y I am calling it as F inverse of Y. When we talk about inverse, we put the variable as Y. Even if you put X, there is nothing wrong. If you put X, you should put X minus 3 by 4. But we will follow the notation of Y itself. So whenever we define the actual function, we will use the variable X. When we talk about the inverse, we use Y. Fine. So all of you can pause the video and take the notes. I'll go to the next one, which is example 24. So e.g. example 24, e.g. 24, e.g. means example, example 24. Now what it says is Y is equal to, so what is given? Given statement is, given is Y is equal to set of all n square such that n belongs to n, right? And obviously it's a subset of n. It's a subset of set of all natural numbers. So this is a symbol for subset. C means it's a subset. Now consider the function. Now F is a function from set of all natural numbers to Y. Set of all natural numbers to Y and defined by, and is defined as F of n equal to n square. Now we have to show that F is invertible and find the inverse of same thing. So to show or to prove, whatever. To prove is, first is F is invertible, and second is we should find F inverse. F inverse is equal to what? The same proof will follow. The same steps will follow. The steps are now first step is to check F is 1 to 1. The same step that we followed for the previous problem. I am not going to change much here. I am just going to change all these according to this function, because the same set of steps we are going to follow whenever we need to show that F is invertible and we have to find F inverse. Right, now to check F is, first step is to check F is 1 to 1. Right, now we'll say let x1 comma x2 belongs to n, which is from this set. So instead of x1, since they have defined it as f of n equal to n square, you can use the variable x1 and x2 also, doesn't matter. In case if you want to change it, we can put it as n1 comma n2, just to be in sync with, since they are talking about it. Even if you put x1 comma x2 belongs to n, if you follow this, there is nothing wrong, right? Or I'll follow the same thing, or we'll follow the different one. That's okay, doesn't matter. I think I'll follow the same notation so that you can use this x1 comma x2 belongs to n such that f of x equal to f of, so x1 comma x2, two elements I'm taking from set n such that f of x1 equal to f of x2. Now we should prove x1 equal to x2, right? Now x1, what is f of x1? F of n is n square, means f of x1 will be x1 square equal to f of x2 will be x2 square. Right, now x1 square equal to x2 square. So which means x1 square minus x2 square equal to 0, which means x1 minus x2 into x1 minus plus x2 equal to 0, right? So which means either x1 minus x2 equal to 0. So this is x1 square minus x2 square, which is in the form of a square minus b square. We can write as a plus b into a minus b, which means x1 minus x2 equal to 0 or x1 plus x2 equal to 0, right? So which means here it gives you x1 equal to x2 or x1 equal to minus x2. But x1 equal to x1 equal to minus x2 is not possible because your x1 and x2 both are coming from natural numbers. So one number cannot be negative of other number. x1 and x2 both have to be positive. In this case, we cannot say x1 equal to minus of x2. So this is not possible. Or we can even here say sum of two natural numbers can never be 0. So this case is not possible. So this is not possible. x1 equal to x2 is not possible. So x1 equal to x2, x1 equal to x2 here because x2 goes here. x1 equal to minus x2 is not possible. We'll say this is not possible. It's not possible. Therefore, we got x1 equal to x2. Therefore, f is 1 to 1. F is only this case is possible. Therefore, f is 1 to 1. We have proved that f is 1 to 1. Now we should show that f is on 2. That is our step 2. Right? So how do we show f is? So step 2. Step 2 is to check f is on 2. And f is a function from, since f is a function from set n to y, where y is the range of f. Because y is what? So y is set of all n square such that n belongs to n, which means all the mapped elements, f of n equal to n square, all the mapped elements are in this set. Right? Which means where y is the range of capital Y. Capital Y is the range of f. So we'll say let R for every y belonging to capital Y, there exists x belonging to n, such that this y is equal to x square, because y is our what form? N square for any n belonging to x. If x belongs to n means y will be of the form x square. All the square numbers y has. So which means such that y equal to x square. And what is your x square? X square is f of x. Or you can call it as f of n. See, variable doesn't matter. You can put any variable. When f of n is n square means your x square is equal to f of x. So y equal to f of x. So we proved that y equal to f of x. Therefore, f is onto function. So what means? What we have proved for every y in this set, we showed that there exists an x belonging to n such that f of x is equal to y. Therefore, that makes f as onto function. Now we will say since f is 1 to 1 and onto, f is invertible. Invertible means f inverse exists. Right? Now we'll go to step 3. So step 1 and step 2 we have proved f is 1 to 1, f is onto. We have proved. Right? See here the function is defined from n to this set y, and y is what? Y is defined as set of all n squares such that n belongs to n means what? All the mapped elements are in this set y. All the images are in y. Which means y is a range of f. Which means for any element that you take from the range of f, you can always find an element in the domain such that f of that element will be equal to y. So that makes f as onto. Whenever you define a function from a set to its range, it will be always onto. Now the third step is we are defining the function g. Now whenever you want to define the function g, we have to write what is y is equal to. We have to write what is y is equal to. So we will say y is equal to I'll say y is equal to what? Y is equal to, we can either say x square or n square, doesn't matter. So I'll put y is equal to x square because your f of x is x square. So f of n is n square means this can also be treated like f of x is equal to x square. So there's no issue with the variable. You can put any variable. Right? F of n is n square means f of x is x square. So y is equal to x square. So you have to put, because every y is in the form of x square, n square means I can also define this as y is equal to x square such that x belongs to n. So y is equal to x square form. N square means you can use any variable. So I'm using the variable x. So we'll use everything with x and y so that you know that x is coming from the domain set and y is from the range or that codomain set. Right? Y is equal to x square. Then if you write now x square is equal to y, we have to write x in terms of y. X in terms of y. So y is x square. We know y is always in the form of x square. So now x becomes what? Plus or minus root of y. So again, x is what? X belongs, this is for every x belonging to natural number n. Y equal to x square for every x coming from this natural number. Now x is a natural number, therefore x cannot be negative of y. Right? X belongs to n, therefore, so x belongs to n. Therefore, x is equal to root of y only. It cannot be minus root of y. In this plus or minus, we can take only plus root y. Because minus root y, if I take, then x will become minus, negative. How x cannot be negative because x is coming from the natural number n. So our function y is x is equal to x is equal to root y. So we have written now x in terms of y. We have written x in terms of y. Now let's define the function g from the set y to n such that g of y we will call it as this one. After whatever we write x in the moment you write x in terms of y, this is called as your g of y, which is root y. But g of y is defined as g of y is equal to, not g of y is equal to root y. G of y is equal to root y. Now we have defined it. Now we have to see, we have to show that our g of f. So g of f will be a function from what? Again from f. F is starting from which set? N. To g is ending with which set? N. So it is from n to n, and we have to find what is g of f of x. And what is g of f of x? It is g of f of x. And what is f of x? It is called g of f of x is what? F of x is f of n is n square means f of x is x square. So this becomes x square. And what is g of x square? G of y is root of y. G of x square means wherever y is there, I have to put x square. So it becomes root of x square. That is x. So your g of f of x is equal to x. So therefore, your g of f becomes the identity function defined on the set n because it is from n to n. Right? It is equal to x. G of f of x we have got because square root of x square is x. So we proved g of f of x is x. Therefore, g of f is identity function. Right? Next, we will go to step 5. Step 5 is f of g function. F of g is also from y to y, and f of g of y is defined as f of g of y, that is equal to f of, what is g of y? So g of y is f of, what is g of y? G of y is root y. So root y, that is equal to, now what is f of root y? F of n is n square, right? Or f of x is x square. So wherever x is there, I have to put x square here. So f of root y will become root y the whole square. This is f of x. F of x is what? X square. That is y. So we have proved f of g of y is equal to y. Therefore, your f of g will be equal to the identity function. So because y is mapping to y. So therefore, f of g is I of y. Therefore, we can say g is the inverse of f, bracket g equal to f inverse. And what is g of y? And g of y is equal to f inverse of y is defined as this one, root y. Root y is the comma. Root y for every y belonging to y. Y is the domain of g. So this is the inverse. So g of y is equal to f inverse of y, which is equal to root of y. Root of y. So this is the function g of y. G is also called as g is equal to f inverse. That's why g of y we are writing it as f inverse of y because g is same as f inverse. We have proved g is the inverse of f. When can we prove G is an inverse of F? Whenever we have G of F equal to In and F of G equal to In. Both G of F and F of G are becoming identity function, then G is the inverse of F and this is the inverse function. So we showed that it is invertible and we have also find the inverse of F. So all of you can pause the video and take the notes. I'll go to the next example, which is example 25, which is very important. Let me erase this. Now example 25, EG 25. Right? See, in the book they have given it very short because they have not given detailed explanation. What they have done it as all right, but they have used some of the properties to prove that. Here we are not using the properties, we are even proving those properties. Right? In the book they say that inverse exists, therefore it is invertible. So they first find the inverse and then they say that it is invertible. But here we are first proving that it is invertible and then we are finding the inverse. Right? Both are same, but this will be in a more logical way or in a detailed explained way. The explanation is in detail here so that anybody can understand very easily. And the concept wise we are explaining each and everything here. So example 25 is F is a function from given is F is a function from set of all natural numbers n to r, set of all real numbers, and defined as f of x is defined as 4x square plus 12x plus 15. So this problem is very important. Board question. Show that what we have to prove. So we have to prove that to show or to prove, whatever, to show that a function f from function f, the same f from n to the set S, where S is range of f, where S is range of f, is invertible. So this function f, which is from n to s, we have to show that it is invertible. Find f inverse. Find the inverse of f. Right? Or I can put it as second part. So this first part is to show that if the function is from n to s, we have to show that f is invertible. And second part is we have to find f inverse. It's the same type of question. F inverse equal to what? Same like the previous problem that we did. Fine. Now let me erase all this. Now again we'll follow those 5 steps. So now here we need to focus on this function f from n to s. We should show that it has an inverse. It is invertible and you have to find the inverse of this function, and this function f is from n to s. Suppose if f is from n to s, then that has an inverse. Right? Not from n to r. This does not have an inverse. But this, if it is from n to s, where s is the range of f. S is the range of f. So solution. Again we have to take step 1 to check the function f which is from n to s is 1 to 1. Right? 1 to 1 function. Now how do we prove that? So we'll say let x1 comma x2 belongs to this set n such that f of x1 equal to f of x2. Now we should prove that x1 equal to x2. Once we prove x1 equal to x2, f becomes 1 to 1. Now what is f of x1? F of x1 is this one, 4x1 square plus 12x1 plus 15, because f of x is this. So f of x1 will be wherever x is there, I am putting x1 equal to f of x2 will be 4x2 square plus 12x2 plus 15. Now plus 15 gets cancelled. Now we can bring everything to one side. So I'll get 4 into x1 square minus x2 square. If this 4x2 square comes here, it will become minus 4x2 square, and 4 I'm taking common, plus here 12x1 minus x2, because this plus 12 comes this side, it will become minus 12x2, so equal to 0. Now here we can cancel throughout by 4. I can take, if you cancel throughout by 4, you will get x1 square minus x2 square plus 3x1 minus x2 equal to 0. So we have to show finally x1 equal to x2. So now here we will write this as, even I could have written here also, that's okay. We'll write this as x1 plus x2 into x1 minus x2, because a square minus b square is a plus b into a minus b, plus 3 into x1 minus x2 equal to 0. Now here we'll take x1 minus x2 common. Then we will get x1 plus x2 plus 3. x1 plus x2 plus 3 equal to 0. Fine. So now this becomes, which means either x1 minus x2 equal to 0, or this value x1 plus x2 plus 3 equal to 0. So this means x1 equal to x2, and this case is x1, so this will be x1 plus x2 equal to minus 3. But this is not possible, because x1 and x2 are what? They are coming from natural numbers. So sum of two natural numbers. Sum of two natural numbers cannot be equal to minus 3, negative number, right? x1 is a natural number. x1 and x2 both are coming from n. Sum of two natural number cannot be negative. So this is not possible. So only this case is possible, which means only x1 equal to x2. Right? This is not possible. So only thing that we have is x1 equal to x2, therefore f is 1 to 1. So we have proved f is 1 to 1. Fine. Now step 2. Step 2 is, now since f from which set? F is from n to s. N to s, where s is the range of f. Right? Which means for every y belonging to this set S, for every element y belonging to the set S, there exists x belonging to n, such that y will be equal to what? Y will be in the form of this one, 4x square plus 12x plus 15. Why? Because f is a function from n to s, where s is the range of f. Range of f means any element that you took from s, that we take from s. Any element that we take from s, it will be in this form, 4x square plus 12x plus 15. Because every element here is going, so this is what? Range of f. Range of f means collection of all the images of this function. All the images of this function is what? F of x, which is this. Which means any element s will be in the form of 4x square plus 12x plus 15 for some x belonging to natural numbers. So any y that we take from s will be in this form. Any element that we take from s, that element I am calling it as y. Any element y I take from s, it will be in this form. And what is this? This is equal to f of x. 4x square plus 12x plus 15 is what? F of x. Because any y that we take from s will be in this form, and it is equal to f of x. So every element we take from s, there exists an x in n such that f of x is equal to y. Therefore, f is onto. Since f is 1 to 1 and onto, f is invertible. Right? Here this f we are talking about is this f. This f. Right? Now step 3. We have defined the function g. Right? I'll say to define function g. To define function g. Now how do we define the function g? Now again we'll have to write first of all y is equal to this. And y is equal to 4x square plus 12x plus 15. Now we should write x in terms of y. Now we have to write x in terms of y. Now how do we write x in terms of y? Which means you have to find the value of x. X equal to what? We have to solve and find x from this equation. So we will write this as a quadratic equation like this. 12x plus 15. And this y will go this side. It will become minus y equal to 0. Right? I am bringing everything to one side. Now this is a quadratic equation in x. It's a quadratic equation in x. So we'll solve and find x. We'll apply the quadratic formula, right? So what is our quadratic formula? X is equal to minus b plus or minus. That is our quadratic formula, right? X is equal to minus b plus or minus square root of b square minus 4ac by 2a. That is our quadratic formula, right? To find the value of x. So now here this is your a, this is your b, and your c is this whole thing. 15 minus y is your c. So let's apply what is our x. X is equal to minus b, which is minus 12. So this is your a, this is your b, this is your c. Minus b plus or minus square root of b square. B square is 12 square. Minus 4 into a. A is 4 into c. C is 15 minus y. By 2a. 2 into 4. Right? So if you simplify this, so x becomes x is equal to minus 12 plus or minus square root of, this becomes 144 minus 16 times 15 minus y by 2 into 4. So x becomes minus 12 plus or minus, now if I take here 16 is common, 144 and 16 common. If I take 16 common and out of the root, it will become 4. 16 will become 4. So it will become square root of, after taking 16 common, this will become 19 minus 15 minus y. Right? Or I can multiply with minus. So it will become, sorry, this is 9. So 9, 144 9s are 16. So once I take 16 out, it will become 4. Then 144 will become 9. Then 16 is taken out already, which has become 4. So you will have minus of 15 minus y, which will become minus into 15 is minus 15 minus into minus is plus y by 2 into 4. Right? Then we can throughout cancel the 4. The 4 is common. Throughout we can take cancel the 4. So x will become minus, if I cancel by 4, it will become 3 plus or minus, this 4 is also gone. Square root of 9 minus 15 is minus 6. So I can write this as y minus 6 by that 4 will be cancelled with the below 4 2. Right? I am taking 4 common from the numerator and cancelling this 4 and this 4. So your x becomes like this. Is it clear? Or if it is not clear, I will write one more step. So which means x is equal to, if I take 4 common, then this will become minus 3 plus or minus square root of, this will become y minus 6 by 2 into 4. Again this 4 is getting answered. So that's what I was explaining in the earlier step. So this becomes minus 3 plus or minus square root of y minus 6 by 2. Right? So, and again, so y is equal to 4 square, this is for every x belonging to natural number. So which means this x will belong to n. This is from a natural number. X is from natural numbers. Right? Now we have got x in terms of y. We have found what is x is equal to. So earlier cases it was very easy. We could move everything to the right side and we got x is equal to something. But here, it was not a linear equation. So it's a quadratic equation. So we had to use the quadratic formula to find x. We had to use quadratic formula to find the x. So we found it. Now let's define g. So g is a function from which set to which set? G will be the reverse of this. So g will be from s to n. If f is from n to s, so don't worry about n to r. We are trying to show n to s is an invertible function. This function which is from n to s is an invertible function. So your g will be from the reverse of this, s to n. It will be from s set to n set. And what is g of y? We'll call this as g of y. This is our g of y. So g of y equal to minus 3 plus or minus, here I'll have to do one more step. So x is equal to this. So here we have plus or minus, which means x is equal to minus 3 plus root of y minus 6 by 2 or minus 3 minus root of y minus 6 by 2. But x is a natural number, so x cannot be this, because this is minus 3, this is also minus. Minus and minus will become again minus. Right? 2 minus, when you add 2 minus, the result is also minus. So this will become negative. So this is not possible. Right? This is negative. So this is negative. Final answer is negative. So therefore, x is only this. Therefore, x is equal to minus 3 plus square root of y minus 6 by 2. Or we can write the other way also. If this is confusing, we can even write the other way. X is equal to, we can write this first. Root of y minus 6, then minus 3 by 2. So this minus 3 is outside the root. This minus 3 is not part of the square root. So this is your x. Now we'll define our g function. So g function will be what? How do we define the g function? So I'll define here. So g is a function from set n to s to n reverse. And what is g of y? G of y will be equal to this one, root of y minus 6 minus 3 by 2. That is your g of y. Square root of y minus 6 minus 3 by 2. This is square root of y. So I am writing this first and then minus 3 here, then by 2. Fine. Now this third step is over. We have defined the g. Now we should do the fourth step. What is our fourth step? Fourth step is we have to do g of f equal to I, and fifth step we have to show f of g equal to I. I am erasing this. I'm erasing this quadratic formula also, which we used here. Right. So step 4. So I'll put a line here. It's step 4. Step 4 is we need to find what is g of f. And g of f is a function from which set to which set. F is from which set? F is from n. Right, this n to s. So it will be f is n to g is ending with s. G is ending with n. Sorry. So it is from n to n. And what is g of f of x? That is equal to g of f of x. That is equal to g of what is f of x? F of x is again f of x is in this form. Right. Now here one more thing that we need to do here is, if f of x is in this form, if you substitute 4x square plus 12x plus 15, then it becomes very difficult to substitute the value in this function. Right. So here we'll do one more thing. So this the point is here, when y is equal to this, we'll also try to express y in the form of, where shall I write it? I'll write it here. See, y is equal to, we have here y is equal to 4x square plus 12x plus 15. Fine. So now our y is equal to, if I try to write this in the form of a square plus 2ab plus b square, I don't have a space here. Let me erase this. So sorry, I'll write it here only. I'll write it here. So we get g of f of x. So I don't know whether I have a space here. Okay, I'll write it here. So after we get this, we will also take, so y is equal to 4x square plus 12x plus 15. Now let's try to write y in terms of x. We have written in this form. We'll also try to write y in a little more simplified way. In the sense, we will write this y as, what is this? This is 4x square plus 12x plus 15. So this can be written in the form of 2x the whole square, which is a square, plus 2 into a into b, 2 into 3 plus 3 square minus 3 square plus 15, method of completing the square. Right. So I am writing this in the form of 12x is written in this form. 4x the whole square is written as 2x the whole square. 4x square is written as 2x the whole square. This is 2 into a into b. Then I am adding b square and subtracting b square. Then this 15 I am writing as it is. See, what is the point in doing this is, in this case we can write this y as, if you take these three, this is in the form of a square plus 2ab plus b square. So it can be written as a plus b the whole square. Then this is minus 9 plus 15, that is y. So y becomes 2x plus 3 the whole square minus plus 6. Right? Y is equal to 2x. So this y, which is equal to this, can also be written in this form. Can also be written in this form. Now let's find what is g of f. So why we are writing, I'll tell you. G of f of, that is step 4. Step 4 is g of f of x we have to find. That is equal to g of f of x. That is equal to g of f of x. Right. So here I hope you have understood. We are using method of completing squares to write this as a square plus 2ab plus b square. These will become, these three will become this, then this is minus 9 and 15. Now that is equal to g of, what is f of x? F of x is, and this is called as f of x. Because your y is equal to this is your f of x, right? This is also your f of x. So your f of x, instead of writing in this form, we'll write it in this form. F of x as this form, 2x plus 3 the whole square plus 6. And that way it is easy when you substitute this in this function, rather than substituting this entire 4x square plus 12x in this. That may be little, taking time, or even if you substitute, there is nothing wrong in that. We will be still, I think we'll be able to still find it. The only thing is we'll have to factorize that carefully there. Anyways, so now if you take this, so what do we get? Now we should substitute this in this. So that is equal to now g of this. So wherever y is there, we have to put this value 2x plus 3 the whole square plus 6. So g of y becomes square root of y minus 6. Y is this value, which is 2x plus 3 the whole square plus 6, y minus 6, then minus 3 by 2. Right? This is y minus 6 plus 3. y minus 6 minus 3 by 2. That is your g. G of this is equal to, now here plus 6 minus 6 will get cancelled. So this will become 2x plus 3. Because 2x plus 3 the whole square root will give you 2x plus 3. This is minus 3 by 2. Finally, you will get it as x. So your g of f of x gives you x. Right? Therefore, your g of f is what? Your g of f is I. I of, it is a function from, f is a function from n to n. N. So it will be a function from in. Even if you put I, it is okay. I put I n because f is starting from n and g is ending with n. So your g of f is a function from n to n. So we have proved that g of f is equal to in. So similarly, let's find step 5. Step 5, probably I will write it here. I will erase this question part. I'll start here. So step 5. Step 5 is we have to find what is f of g of y. F of g of y. When it is g, we will put y. So that is equal to f of g of y. That is equal to f of, now what is g of y? G of y is square root of 4 minus y. So that is equal to square root of y minus 6 minus 3 by 2. So that is your f. Now what is g of y? G of y is this whole value. Now f of this we have to find. Now f of this, finding this, we can use this function, but substituting this value in this will be very difficult, and expanding, say 4 into x, in the place of x you have to put this big thing, then plus 12 into this whole thing you have to put. So substituting here may be difficult. That's why we will use this function to substitute this. Right? So substitute this, we'll use this function. So now what is f of x? F of x is 2x plus 3 the whole square plus 6. So that is equal to, so f of x is this one. Which means the place of x, if x is here, I have to put the x here. In the place of x, I have this. So I will write it as 2 into x. X is what? X is this. Root of y minus 6 minus 3 whole divided by 2. That is 2x. I have written x. 2x plus 3 the whole square plus 6. Fine. So this is f of x is 2x plus 3 the whole square by 6. So what will happen? The 2 will get cancelled. Right? So what do we get here? Let me erase this one. If they get cancelled, then we'll get root of equal to square root of y minus 6 minus 3 plus 3 the whole square plus 6. So these two will get cancelled. Square root of y minus 6 the whole square will give y minus 6, and this is plus 6. Finally, you will get y. So what we have proved? We have proved f of g of y is equal to y. Therefore, our f of g is equal to I of y, because g is a function from, sorry, s, we will put I of s. Why I of s? Because g is starting from set s and f is ending with s. So it is from is. So therefore, we have proved that f of g is also I. G of f. G of f is also I. F of g is also I. Therefore, I'll erase this particular step also. All of you please pause the video and take these notes. I'm going to erase a little bit here. Right? So I of s. So therefore we'll say, therefore g is the inverse of the function f. G is the inverse of f, which means g equal to f inverse. And what is g of y? G of y is equal to f inverse of y. We are writing what is f inverse of g of y? This that is equal to square root of y minus 6 minus 3 by 2. So this is the inverse of the given function f, which is from n to s. Right? And obviously, so g is, and again your g is function from, g is the inverse of f defined by this, and g is a function from s to n. G is a function from set s to n. Fine. So this is the end of this. Right? Fine. So all of you can pause the video and take the notes. So this completes the example 25. So all of you can pause the video and take the notes. And I'll stop the session here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.